friends, in this video we will study the block diagram of 8259 Programmable Interrupt Controller, which is also known as PIC. So let's start with our topic. The programmable interrupt controller, it is used by the microprocessor systems like 8085, 86, 88 and 80 for handling the multiple interrupt systems. Whenever the microprocessors, they are having multiple interrupts, then to handle these interrupts, it uses a controller, which is the programmable interrupt controller 8259, the PIC. And this controller, it handles the functions like it takes care of the priorities of the interrupt, that which interrupt is having the highest priority, which is having the lowest priority, and also the type of interrupt which is given to the microprocessor. So all the tasks related to the interrupt operations in the multiple interrupt systems, they are handled by the programmable interrupt controller 8259. So in this video, we are going to study the block diagram of this IC 8259. So let's see the block diagram of this PIC. This is the block diagram of the 8259. In this block diagram, you can see that there are various blocks, and these blocks, they represent some of the elements of the 8259. This block, it is the data bus buffer. It is the bidirectional data bus, and this bus is also connected to the internal bus of the 8259. Then we have a block which is named as read and write logic. One block is for the cascade buffer and comparator. One is for interrupt mask register, in-service register, priority resolver, interrupt request register, and control logic. Now to these blocks, various signals are connected, like for the interrupt request register, we have the various interrupt requests, IR0 to IR7. Then this cascade buffer or comparator, it has the slave program or enable pin is also connected. This are the cascade lines. Then we have chip select, A0, read and write signals here, and this is the bidirectional data bus. So these are the various signals which are connected to these blocks. So let us study the function of each of these blocks one by one. First, we will start with the data bus buffer. This data bus buffer is a 3-state bidirectional 8-bit buffer. 8-bit buffer because the data bus, it is also of 8 bits. So the buffer associated with it will be a bidirectional 8-bit buffer. So we can say here that this is a 3-state bidirectional 8-bit buffer. Now this buffer, it is used to interface the 8259 and the system data bus. Okay, you can see here that this data bus buffer, it is connected on one side with the data bus of the microprocessor, and here it is connected with the data bus of the 8259, that is this internal bus. Okay, so whenever any data has to be transferred between the 8259, this controller, interrupt controller, and the microprocessor, then this data bus buffer, through this buffer the data is transferred. So whenever transfer has to take place, this buffer has to be enabled. Okay, so when this buffer is enabled, then the data transfer will take place. Otherwise, if it is disabled, then no data transfer will take place. So we can say that this buffer, it is used to interface the 8259 with the system data bus. Now the data which is transferred from the 8259 to the microprocessor and from the microprocessor to 8259, what this data can be? This data can be either the control information, that is it can be a command word, or it can be the status of the interrupts, that which of the interrupts are pending, which of the interrupts are in service, means which are executed at that time, and which are pending. Okay, so about the information about the status of the interrupts, about the command words, the data can be anything. Okay, so this data, it is transferred through this data bus buffer. So the control words and the status information from the microprocessor to the programmable interrupt controller PIC, and from PIC to the microprocessor, they are transferred through the data bus buffer. Control words means they are the command words, means in which mode the 8259 it is working. Those modes, they are decided by the control words or the command words. So these control words are provided by the microprocessor to the 8259. And status information means the information about the interrupts, like masking information, pending information about the interrupts, and the interrupts which are currently executed by the microprocessor. So all the information regarding the interrupts, that is transferred from the programmable controller to the microprocessor. So any type of data transfer between the 8259 and the microprocessor, it takes place through this data bus buffer. So this data bus buffer, it is to be enabled or disabled for the data transfer to takes place. Now this data bus buffer, so this data buffer has to be enabled or disabled for the data transfer to takes place. Now this data bus buffer, it is enabled or disabled by using the pin of the 8259 IC, which is known as the SP or the enable pin. This is the SP bar or the enable pin. So when this pin, when the 8259, it is working in the non-buffered mode, it is not working in the buffered mode. So this enable pin, when it is set to 0, then the buffer, it is enabled, and when this pin is 1, then the buffer is disabled. Okay, so this enabling and disabling of the data bus buffer, it is done through this pin SP or enable pin. It has a dual function. It can work as SP also, means slave program, and as enable pin also. Now the next block in this block diagram, we have studied about the data bus buffer. Now next comes the read and write control logic. To this block, 4 signals are connected. One is read, write, A naught, and then chip select signals. Okay, so let us study the function of this block. What this block does. Now the function of this block is to accept the output commands sent from the CPU. Because this block, it has both the signals read and write signals. So read signal, it is used to read the status of the interrupt request, and whatever it will be the status of the interrupts, that will be read from this read and write control logic. Okay, so when this signal is low, then the status will be read by the microprocessor, and when this block will have this write signal. So when this write signal is available, then the microprocessor will give the command words, and those command words will be written into the control register of 8259. So this read and write logic, this block, it is providing the signals to enable the read and write communication between the microprocessor and the 8259. So the function of this block is to accept the output commands, means the control commands sent from the CPU. Okay. Also the function is, now these output command means command words, they contain the initialization command words also and the operation command words also. There are two types of command words in the 8259: initialization and operation. So initialization command words, they are used to initialize the IC 8259, and the operation command words, they are related to the modes of operation of 8259. So these two types of command words, they are given by the CPU to the 8259 when the write signal is enabled in the read and write control logic block. So initialization command words, that is ICW, and operation command words OCW. These command words, they store the various control formats for the device operation. Means for the operation of 8259, the various modes of operation. So the various types of control formats, they are available and they are stored in the ICW and OCW. Okay. Now, as this block, it has both the signals read and write. So through write, the command words are given to the 8259. Now, through this read signal, the status of the interrupts will be read by the microprocessor. So another function of this block is to allow the status of 8259 to be transferred to the data bus. So whatever will be the status or whatever are the command words, they are transferred from the microprocessor to the 8259, and vice versa also when the read and write signals, they are enabled in this block. Okay, so then only this transfer of data will take place. When read is 0, means read is enabled, then the data will be read, and when write is enabled, then the data will be written. Now we have the A dot and CS bar signals also. CS bar, it is the chip select signal. So when this signal is low, then only this chip 8259 will be selected. If it is not active, means if it is made 1, then this chip will not be selected and no communication will take place between the 8259 and the microprocessor. At this A dot address line, this is used to write the control words in the control registers. Okay, so this will be used for the various modes of operation of 8259. So this is the function of the read and write logic block. Okay, now next come to the interrupt mask register. Okay, so this was the read and write control logic. Now next block in this block diagram we have is the interrupt request register. So let us study the function of this interrupt request register. We know that the 8259, this programmable interrupt controller, it can handle 8 interrupts at a time. Okay, so for these 8 interrupts, we have the 8 input pins. These are the 8 input pins from IR0 to IR7. So these are the interrupt pins which accepts the interrupt request from the various devices which want to interrupt the microprocessor. Okay, so they will first send the interrupt request to the 8259, and these requests are stored in this interrupt request register. Okay, so the function of this block is to store all the interrupt inputs that are requesting the service. Okay, so all the interrupt requests, they will be stored in the IIR register. Okay, so this is an 8-bit register. So 8-bit register means 1 bit is for each interrupt request, that is from IR0 to IR7. So 1 bit is assigned for one interrupt request, so it is an 8-bit register, and 1 bit is for the each interrupt request. Okay, so this interrupt register, this interrupt request register, it basically keep tracks of which interrupt inputs are asking for service. So in this IIR register, we have the 8 lines, IR0 to IR7. Okay, so which line is set means, if suppose IR0 is set, it is 1. It means that the first interrupt register or the first device, it want the service. Okay, now if IR6 is 1, that means that the sixth input output device, it wants service. So it is basically this register, it is keeping a track of that which interrupt inputs they are asking for service. Okay, now if any of the interrupt input it wants the service, then the corresponding bit of that interrupt will be set to 1. Means if sixth input output device want to communicate, then IR6 will be set to 1, otherwise it will be 0. If seventh input output device want, then IR7 will be set to 1. Okay, so in this way the input output, the pins, that IR6, IR7, they shows that the, so this 8259, it can connect to 8 input output devices, and these devices can send the interrupt request to the microprocessor. So suppose that this is 8259 and we are having the various input output devices connected to it. Okay, 8 input output devices can send the request to it. Now suppose that this third input output device, it is sending the request to this. So this is for IR0, this is IR1, this is IR2. So when this IR2 bit it is set to 1, it means that this third input output device, it wants the service of the microprocessor. Okay, so in this way, whichever interrupt input it want the request or it want the service, then that bit will be set to 1. Okay, so if it is 1, it means that this input output device wants to communicate. So the content of this register means the interrupt request register. It can be read to know the status of the pending interrupts, that which of the interrupts are pending. Suppose that this IR2 request, this input output device, it is sending the request to 8259, and in response to this request, the 8259, it is going to give this interrupt output signal to the microprocessor. Okay, Now the microprocessor, it has received the request. In response to this request, the interrupt this microprocessor, it is going to generate interrupt acknowledge signal. Now when this request has been asserted by this microprocessor, then again this bit is set to 0. Again this bit is going to become 0. Now simultaneously, if 2 or 3 interrupts are coming, like IR2 is also coming, IR4 is also set to 1, IR7 is also set to 1, but IR2 is having the highest priority. So first this will be asserted, or this will be accepted by the microprocessor. Now as soon as this is accepted or read by the microprocessor, this bit becomes 0. Now the microprocessor is going to check, or the 8259, it is going to check that which of these bits are 1. Now IR4 and IR7 are 1, so it means that it is also giving the information about the pending interrupts. Okay, when IR2 is executed, IR4 and IR7 are the pending interrupts. So it is also giving us the information about the status of the pending interrupts. So these are the two functions of this interrupt request register. That first, it is showing that which of the interrupt inputs they are requesting the service of the microprocessor, and also it is showing us the status of the pending interrupts. Okay, so in the block diagram you can see that the interrupt request register, it is having the 8 input pins, which are the IR dot to the IR7, that is the 8 interrupt pins. And these interrupt request register, it is giving its output to the priority resolver also, and to the in service register also. So now we will study the interrupt mask register, which is giving its output to this IIR. Okay. So next block we will study is the interrupt mask register. This register is known as the IMR, and as the name says that this is used to store the information about the mask interrupts. Okay, so whichever interrupts they are masked by the microprocessor, the information about those will be stored in the interrupt mask register. Now this register, it is also an 8-bit register, so 8 bits are assigned for the 8 bits of the mask registers. Okay, here we are having the IR dot to IR7, so here also we will have the 8 bits for these 8 interrupts, and whichever bit is set to 1, it means that that interrupt request has been masked. Okay, so this register is used to mask or unmask the interrupts. So this IMR register, it is used to mask or unmask the individual interrupt request inputs. Mask means which are disabling, we are disabling the interrupt, and unmask means we are enabling the interrupt. Okay. Now this register, it is also an 8-bit register. So each bit of this register, like it will be IM0 to IM7. Okay, just like in the interrupt request register, we were having IR0 to IR7 for the 8 interrupt request. Okay, so for each of the interrupt request, we have the masking bit also. Now suppose if the request is that IR2 is equal to 1, it means that this interrupt request is being given. Now if IR2 and IR4 is also 1, It means two interrupts are simultaneously given. Okay, but IR2 is having the highest priority, and IR4, suppose this is masked. Okay, so the bit for IR4 will be IM4, and that will be set to 1. It means that this register has been masked and only the IR2 interrupt request will be executed. Okay, so each bit corresponds to the interrupt input with the same number. For IR dot, we will have IM dot. For IR7, we will have IM7. For IR2, we will have IM2. So for corresponding bits with the same number, it is going to represent. Now this interrupt mask register, it operates on the interrupt request register. Okay. So this IMR, it is going to give its output to the IIR. Okay. Now suppose that three interrupts are simultaneously given. Let's take an example that IR4, IR6 and IR7. These three interrupts are given. Okay. So each of these bits will be set to what? Now among these three, the IR7 is having the highest priority, and IR4, first IR7 is having the highest priority, then IR6 and then IR4. Okay, so IR7, it is being currently executed, whereas the IR4 is, suppose it is masked, so IM4 will be set to 1. Okay, now when we are masking, the higher priority input will not affect the interrupt request lines of lower priority. Suppose that among these three interrupts, if IR7 is masked, so IM7 is equals to what? Okay, now if this is masked, it will not affect the interrupt request of the lower priority interrupts like IR6 and IR4. They will be executed according to their priority. Okay, so masking of higher interrupts, it does not affect the interrupt request or lines of the lower priority interrupts. So this interrupt mask register, it is masking or unmasking the interrupts. If you want to mask the interrupt, then that bit is set to 1. If you want to unmask the interrupt, then that interrupt pin will be set to 0. Okay. Next, we have the interrupt in service register. Okay. You can see in the block diagram, we have studied the IRR, interrupt request register. IMR we have studied. Then we are left with this in service register, that is ISR. So this ISR register, it gives us the information about the register about the interrupt request which is currently being processed. Okay, so IRR means the interrupt request register, that gives us information about the interrupt request given by the interrupt units. Okay, IMR, it gives us the information about the masked or unmasked interrupts. In service register, it gives us information about the interrupt requests which are currently being processed by the 8259. So this in-service register, it keep track of which of the interrupt inputs they are currently being serviced. Okay. So if suppose any of the interrupt which is currently being serviced, so the corresponding bit of that interrupt will be set in this in service register. So we will have in service like IS not to IS7 for all the 8 interrupts. So suppose if IS4 is equal to 1, it means that currently the fourth interrupt request is being processed by the microprocessor and the 8259. So this interrupt is in service at that time. So the interrupt which is currently service, its corresponding bit will be set to 1. Okay. So suppose that this IS4 it is in service, and in between the service of this interrupt, another interrupt which is having higher priority than this interrupt, it is active. Okay, suppose that IR 6 is having higher priority than this interrupt. Okay, so IR6 become active and it will be first acknowledged, and then this IS4 will be acknowledged. Okay, so during service of an interrupt also the priorities can be decided or the priorities can be changed. Okay, so this bit IES not to IS7, these bits are used to see that which of the interrupt is currently being serviced by the microprocessor and the 8259. So if more than one bit of the ISR register it is set, it indicates that the number of interrupts being serviced by the microprocessor. Suppose IS4 is also set to 1, IS6 is also set to 1. So if more than one bit is set to 1 or it is set, then indicates that two number of interrupts are being serviced by the microprocessor, 3 is serviced. So that indicates the number of interrupts being serviced by the microprocessor. So if we see that these three registers in the block diagram, if we see that these three registers, the in service register, interrupt request register and interrupt mask register, these three registers are giving us the status of the interrupts. They are giving us the information that which of the interrupts requests are being given to the 8259, which are masked, which are pending and which are in service, means currently being processed. So these three registers, they gave us the information about the status of the interrupts. So we can say that these three registers can be read as status registers. So these three registers combinedly form the status register. First is IRR, interrupt request register. Second is the in service register, and third is the interrupt mask register. Okay. Now next block comes is of the priority resolver. Now, when multiple interrupts are given to the 8259, then how the 8259 is going to decide that which interrupt is it has to acknowledge first, which is at the second number. So priority has to be decided between these interrupts. So we have this block priority resolver which decides the priority of interrupts, that is the sequence in which they can be executed. So this priority resolver determines the priorities of the interrupts which are set in the interrupt request register. Suppose that three interrupts IR0, IR3 and IR6, they are set in the interrupt request register. So those among these three interrupts, which interrupt has the highest priority, which is having the lowest priority, that will be decided by the priority resolver. So this priority resolver, it takes information from the three registers IRR, IMR and ISR to determine the priorities among the interrupts. So when it is taking the information from the three registers. So suppose that register which is an interrupt which is having the highest priority, so that interrupt bit will be set to 1 in this in service register. So the highest priority interrupt pin will be set to 1 in the in service register, because it will be first accessed by the 8259, and then correspondingly the interrupts priority will be decided. Okay, so in this you can see in the block diagram we have the priority resolver which is in between the interrupt request register and in service register, and it is getting input from these three registers to resolve the priority of the interrupts, the 8 interrupt pins. Okay, now next we are at this cascade, buffer and comparator. Okay, so next block was cascade, buffer and comparator. Now to this block we have the 4 lines, which one is the SP and the enable line. Now this line, it decides that whether the 8259 IC it is working in the master slave configuration, or also this signal is also used to enable or disable the data bus buffer. Now, if the 8259 it is working in the master slave configuration, then these 3 lines are used, cascade lines, and these lines act as the local bus to transfer the data between the various 8259 ICs which are in the master and slave configuration. So this cascade buffer and comparator, this block it stores and compare the ID of all 8259 in the system. So when this block it is basically used when the 8259 it is working in the master slave configuration. So in the master slave configuration there are various ICs of this 8259. So this block it decides and compares the ID that which 8259 IC it is acting as the master IC and which IC is acting as the slave IC. So the storing and comparing of the IDs it is done in this block. Okay, now this block it has the 3 lines, cascade lines, CAS0 to CAS2, CAS0, CAS1 and CAS2. Now these 3 lines they are used as the output lines when the 8259 IC it is used as the master IC. Okay, and when it is used as the slave IC, then these lines are used as the input lines. Okay, now master and slave configuration it is decided by the signal SP. Okay, so when this signal it is 0, it means that the ICs are in the master slave configuration, and when this is 1, then the ICs they are not in the master slave configuration, and it has to be used as the input lines. Okay, so this is the function of this cascade buffer and the comparator which is used in the master slave configuration of the 8259. So in this block, now we are left with this control logic block. Now this control logic block, it has the two signals, INT and the INTA bar. Now this interrupt request, when it is given to the 8259 and the priorities are also resolved, then this information is given to the control logic block, and this control logic block will generate a signal INT, and this interrupt signal, it is going to interrupt the microprocessor. Okay, now when the microprocessor, it gets this signal, it get to know that this request, this input output device had sent the interrupt request, and in response to this signal, the microprocessor generates the interrupt acknowledge signal. And when this signal is given to the control logic block, then control logic block, it is going to get the address of the service routine, and then microprocessor is going to execute the service routine written at that memory location. So in this way, the various blocks of this 8259, they work. We have studied the function of all these blocks in detail in this video. So I hope that this topic is clear to you. Thank you.